learn it if possible, and we can only upload and we are in
Because
learning stage.
actually, what happens in case of the Max 2 session, Subhasis sir generally what he used to do, he used to upload the session record, whatever writings are there, if any live sessions is there or solution, it is
Hmm.
uploaded by him only, I think so. Because
By him on the portal, is it?
yes, because it's a shared drive. Generally, it is drive only which is shared. The link is
Hmm.
shared in that drive, Google Drive.
Hmm.
So when the sessions gets over, he used to say that he will upload right after the end of the session, and that recordings are all available in the session itself. After within 1 or 2 hours, we can check and it is available. So I think so. It will be. It is possible by you also. I think so. You can
Okay.
discuss them
Yeah, yeah,
exactly. I don't know, but this was I think.
okay. Yeah, see, if possible, we will try to learn what are the things needed to learn to get it uploaded. We will try to learn and we will do it by ourselves. That would be better. So that will be like a direct conversation between you and us. There will not be any intermediate. So, okay, see, I understand there are lots of things are happening and we have to resolve many things. But give us
Sir,
some time to resolve and we will come up with best solution.
sir, in Maths 1, you also used to upload the solutions immediately, that writings of the PDF.
See, in Maxon, what happened is whenever we send it, they will upload it immediately. So even I
Okay.
will not upload. Even I will, right after the session, we will send the mail, like we will send this PDF to them to upload. But what happens is after 6 or 7, they will not be available. They will be coming to the office in the next day,
Okay.
and they will see
Okay.
it on the next day, and then they will upload. We will check. We will check about this.
Okay. Okay, sir.
Yeah,
Fine.
so that is what my
Let us start,
request
sir.
is. Yeah, my request
Yeah.
is
Yeah.
give us some time. We will try to resolve each and every problem. Okay.
Sir, one more request I want to make, sir.
Hmm. Hmm.
It is sort of motivation for us.
Hmm.
Sir, do you have any statistics on any placements which have been made for the first diploma batch? Just if you could share some information
Uh,
regarding
uh,
placements with us.
no. I don't have any information, but I do know that few companies are coming not after diploma. They will be allowed to sit for placements after degree level.
Okay.
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 So
Okay.
yeah, as of now, see, my I don't know much about that.
Okay. Okay, sir.
Hmm.
Fine.
Okay. So today let us start with this probability density function.
Sir,
Hmm.
I have a doubt just above this page. Can you please clear that?
Let us recall few things in the past from the past session. Yeah. Where?
Yeah, this question, sir.
Hmm.
Probability of x is less than 3.
X
Well,
is less
less
than
than
3.
minus 3. Less than minus 3, sir.
Hmm.
I have a doubt in that because if you see the function,
Hmm.
f of less than minus 3, it will go on. So please have this. It will go here,
Hmm.
and there is a
Minus.
slope.
This is minus 3.
Yes, sir. This is minus 3. Then
Hmm.
how it computed 0? See the solution, sir.
Acha.
For a continuous random variable, for probability for at any particular point will be zero.
But sir, at a particular
Hmm.
point,
This is not
this
at a
is
particular point.
this
Yeah.
is not a particular point.
Okay. Let me try to solve it. Let us try to solve the problem, and we will
Sir,
identify.
sir,
Huh.
sir, here I have one doubt that
Hmm.
CDF 1.2.3, that thrown of a die. How it will I did understood actually if x is less than equal to 3, 2 to 3.
I didn't get. Is it related to this question or
No, no,
some
no.
other question?
some other. It is CDF 1.2.3 in this book only. Whatever say on
1.2.3. Can you tell me the page number?
Page number is 6 page.
6.
6.
Okay. I will go to 6 after solving this particular problem. Okay.
Okay, fine. Yeah.
Let me solve this first.
Okay.
Sir,
So
would you be uploading the last session's that recording, because it is available for only 2 minutes?
that is a serious issue from our side. We didn't record anything, right? We directly streamed it. Even today's session is being streamed. I don't know when this will get stopped, or is it being
Sir,
recorded?
actually, sir, you were that week.
Sir, give me
and
some
two
time. I will
revision
check and
session.
report.
Yeah, Krishna ji.
Actually, sir, this week 1 and 2 revision session also, the second session, there was that link was not working, and luckily now it is working. So, yeah, please ensure, sir, that the revision sessions and all, if the link goes off, then it will be difficult.
Correct. See, we will twice check. We will also check before starting the streaming. Okay. We will do
Sir.
one thing. We will try to start the streaming.
Sir, live streaming is running and it's
Running,
working
right?
fine.
Yeah,
it's
working
running
fine. Okay. Then it will not stop until and unless I stop. It will not stop, is what I am hoping.
Yes, sir.
Okay.
Sir, I am really frustrated about searching the recording and materials. It is not available most of the time. As the
See, if you wanted
Google
to
Calendar.
that is the best method. Just
No.
open your Google Calendar.
Yes, but recording is not there. If I click on the YouTube,
Some recordings, correct.
yeah,
No, sir. Actually, some
sometimes
recordings.
the material
Sir,
which
this is really
not available.
serious issue, sir, because I haven't joined the last session of statistics student and I want to see that lecture, but now that session is not available on YouTube, sir.
Yes, sir. Me too, sir.
See.
Yes, sir. I was looking for the last session recording, but it is not there, sir. Now it's
Okay.
it's very tough for me to go.
Note and with calculation is not there. Only the material is there.
And week 4 is very tough for me, sir. Actually.
See, as I already said in the initial start of this session, give us some time to rectify all our mistakes. So we'll try to come up with a new plan, or we will try to do the best possible that we can do. But give us some time, okay?
But yeah, sir, please ensure that from next time it should be recorded on the YouTube, sir. Please.
Sure. See, whatever we are doing, we know whatever we are suggested to do, that is what we are doing. So this is the very first time instructors are directly streaming, okay? Even we don't know how to do. So sometimes it is being stopped and we don't know what is happening. As far as my session is concerned, but for the last revision session, what I thought is whatever I am discussing now, that is what being YouTube streamed directly. But there is some 2 to 3 minutes gap in the YouTube and what I am teaching here online. So that I didn't calculate and I just stopped the streaming here once I am done here. So there is some gap there. But I'm saying, right, we are in a learning process, this YouTube streaming and everything. So give us some time to rectify our mistakes. That's it. That is what I request.
Okay, sir. Okay. Thank you.
Okay, sir.
Okay. So let us try to solve this particular problem. We have been given a CDF of a random variable x. So this is said to be the CDF. And when x is less than -5, it is being 0. So you can see the CDF graph also. So when x is less than -5, it is being 0. When x is in between -5 to 0, it follows something like 0.04x plus 0.2. Okay, so from 5 to 0. So it is a straight line and it will go like this. Similarly, from 0 to 4, it is given like this, from 1 to 4. So when x is greater than 4, it is 1. So now from here, if you know what is support, what will be the support of this random variable? Okay, okay. We are at to discuss support, right?
-5 to 4.
-5 to 4, but this is the CDF. And once the CDF is given to us, if we wanted to compute, I think the answer is wrong here. So if I wanted to compute
It is
probability
incorrect,
that
sir. It is 0.08.
if I wanted to compute probability that x is less than -3, it is actually being equal to x less than or equals to -3, because probability that x is being equal to -3 is 0. So any continuous function, probability at a single point will always be 0. So this can be equated to this, and this we know this is the CDF fx of -3. So just substitute -3. So if x is -3, I have to substitute here. So
Sir,
0.0.
can I ask a basic question, sir?
Just a minute. Let us try. Let me solve this, and I will take it.
Okay.
So x is -3. So x -3, it follows this equation. So just substitute -3 in place of x here. So 0.04 into -3, that will be minus 0.12 plus 0.2. This will be 0.18. Sorry, 0.8. Correct?
Yes, sir. Just about this question, there is also one problem. Is the answer mistake or something else?
So, okay. So this answer should be 0.08.
Yes, sir. I understood.
Okay.
And this one, second one?
Second one, it's discussed in the lecture also. If you see, probability that alpha less than x less than beta, if it is like this will be equal to fx of beta minus fx of alpha.
Yes, sir. But the answer, I think.
This one is also incorrect because it should be 0.08.
Yes.
Okay. So f of -1, compute f of -1. So f of -1 also lies here. So f of -1 is 0.16. Yeah.
Sir, and just
0.8, and this will be 0.08. Okay, let us. Okay, we will try to correct this again. Okay. Yeah.
Just above this question, sir.
Just above.
Yes, sir.
Even here also.
Yes, sir. The first question, sir.
Yeah, even here also the same mistake. So just compute f of -3. F of -3 will be 0.2.
0.2. Yes, sir. So I was confused in this because I computed what is correct, and the given slide there is a wrong answer. Okay, thank you so much, sir.
Okay. So
Sir,
f of
actually, I don't know how to ask. Actually, I'm really confused about CDF and PDF. The same formula will apply in both the case.
no. See, when we deal PDF now, you will try to get. I hope you will get some idea about it. Okay, page number 6. Someone asked about a doubt. Page number 6. Page number 6. Is it there?
Yes, sir.
Yeah.
This one question, second question.
Which second one? This one. Throwing a die.
Yes, sir.
So consider a random variable x that represent the outcome on throwing a fair die. Okay, the outcomes are 1, 2, 3, 4, 5, 6. So let us say x is uniform. So it is a fair die. So it will follow uniform 1 to 6. Now I have to find the CDF, right? Is that the question? Okay. So now you see x can take 1. Correct? X can
Sir,
take.
can you give one example just where we apply CDF and where we apply PDF?
So 1, 2, 3, 4, 5, 6. The range of Tx is 1, 2, 3, 4, 5, 6. And each of them having probabilities 1 by 6. 1 by 6.
It is a discrete distribution, no?
Discrete. This is a discrete. Okay. Now, what we want is the CDF. How to write the CDF of this function? Sorry, how to get the CDF function of this random variable. So in order to get that, let me see. So what is CDF actually? CDF is a function, right?
Cumulative distribution function.
Cumulative distribution function,
First two
where
digits.
this function is, so the domain is real and it goes to 0 to 1 interval. It will map to 0 to 1. Correct? Set of all reals mapping to 0, such that fx of x is
0 to 1 means probability is between 0 to 1.
probability.
0 to 1 means all the outcomes are what?
No. See, this is a function. You know what is a function, right? So CDF
Yes.
is a function. CDF is a function, and this function maps from set of reals to closed interval 0, 1. Okay. So this is the domain, and this is the range or codomain. So range will be in between 0 to 1. So when I input x, small x, so this x comes from real numbers. So when I take any real number, this fx of x will always be within 0 to 1, will always be any number in between 0 to 1. It will not go less than 0 or it will not go greater than 1. So that is the function. This is how we define this function, and this function is called cumulative distribution function.
And it is applicable for all the CDF.
All the CDF.
Okay.
So any CDF has some properties, right? So those properties are the CDF value will not go below 0, will not go beyond 1, correct? And also fx of minus infinite is 0, fx of infinite is 1. So these are few
non-decreasing.
And also it is non-decreasing function. So there will be few properties, and this is a function. First of all, you should understand that this is a function, and function has some domain and some codomain, and the domain is set of all real values. So this x, whatever you are seeing x, can take any real value from minus infinity to plus infinite. And once you take any real value, this fx of x is defined like this. It is actually probability that x is random variable x takes values less than or equals to that small x. And this, as this is probability, therefore the outcome will always lie in between 0 and 1. Okay, that is CDF. So now we have to find this function throughout the domain.
Sir,
so from minus infinity.
I have a doubt, sir.
Yeah.
Like I have seen a graph in the pages you are scrolling. Like we have a graph of step functions, right? Like the step function is taking value 2, 4, 6, 8. Let's suppose this is a value that the step function is taking, right? So what is the value that exactly that function is taking? 3. I mean 2, 4, 6. But I want to find the probability that a function is taking value 3. Will it be 0 or something else? I mean, or it will non-negative, non-zero.
So your steps are at 2, 4, 6,
2, 4, 6, 8. Yes, sir.
And you wanted to compute the probability that x taking value 3.
Yeah, exactly 3.
Exactly 3. If that is just the straight line, then the probability
yes,
will be 0.
Like this function. Like this. Yeah.
If you wanted to compute 1.5, probability that x being 1.5.
Yes, sir.
Okay. So as there is no jump in the CDF, the left hand probability and the right hand probabilities are same.
Sir, what is the difference between jump and steps? I thought it's the same. Like jump and steps are same, sir.
Jump and step. So this is 1 step, 2 step,
okay,
3 step, and these are jumps.
Okay. Jump. Okay,
sir.
Okay, sir, got it.
Okay.
Now, if I'm finding the probability exactly 1.5 is taking in that case.
Exactly 1.5. You see, exactly 1.5 is probability that x takes less than 1.5, and then so something before this and something after this is also same probability. So that means there is no change in the probability. What I meant is probability that x less than 1.4 is equals to probability that x is less than 1.6.
Okay.
So both the
So-
probabilities are same.
What if it is x is equals to the 1.4? I mean, is it like same or different?
See, what I meant from here is, see, probability that x less than 1, probability that x less than 1.6, I can write it like probability that x less than 1.4 plus probability that 1.4 less than x less than 1.6. Can I write it like this? Can I split this terms?
Yes.
Okay, sir. Yes.
Yes, and this
Yes,
will get cancelled, and probability that 1.4 less than x less than 1.6 is 0. So within 1.4 to 1.6, the probability is 0. X will not take any values in between 1.4 to 1.6. Even though you take probability exactly equal to 1.5, that will lie in this interval, and that will also be equal to 0.
Okay. I mean, if you, in step functions, if you find any probability which is exactly equal to any point which is not a value which is taken by x, then it will be 0.
0.
Okay.
So in
How
this,
can we
This is a mixture, no, sir? This is a mixture. I mean, this is not a discrete and a continuous. This is a mixture, sir. Or this is a discrete.
this is discrete. This is not mixture.
Sir, I have a doubt in this. Sir, actually, we were talking before that probability of A less than X less than B. In that, we were telling that probability of B minus the probability of A.
That's not probability. That's this CDF function.
Sir, in this case, since the slope is 0, can we conclude that?
So, is it same applicable even in this, sir? That is a P of 1.4 less than X less than 1.5. That is a function of 1.6 minus function of 1.4. It is same, so it is 0.
It is 0. That is what it will happen. That is what we are. I am trying to convey.
Okay. So the same logic applies here.
That is why.
Sir, I have a doubt in activity 4.2 question number 7.
Sir, here in the previous page, could you please in here f of the 2 less than equal to 3, x is less greater than equal to 2 less than equal to 3. So how it will be p of x of 2 and it will be 3 plus 3 we are adding p of x is equal to 3. See, I didn't understood that. It is the same thing. 1 is less than equal to x is less than 2. There we are calculating a p.
Okay. This is 1 and this is 2.
Yeah, so that's what I am confused. Okay.
No. This is 1 and this is 2.
Yeah, I understood.
So from in this step, it is 1, 2, 3.
Correct.
Like this it will
go. Okay. I got it.
Yeah.
Hello. Sir, I have a doubt in activity 4.2 question number 7, sir.
Activity 4.2 question number 7.
Yes, and the question we have to find what is the probability that px is equal to the 0 plus px equals to the 1 question.
Just a second, let me open it, okay?
Okay, sure. Question number 9, sorry. Question number 9.
4.2. Question number 9.
Yes, sir. So here px equal to the 0 will be 0, right?
Px is equals to 0 will be 0, correct?
And px equals to the 1 will be the step length, right? 0.6 minus 0.2, right?
0.6 minus 0.2, right?
Okay, I thought p of x equals to the 1 will be 0.6, the total length, I mean.
No. What is the answer given?
It's 0.4.
0.4 only, right?
Yeah. But I have done in a second way like probability that x is equal to the 0 will be 0.2 and in like this.
No.
Okay.
So just now we discussed, right? Whatever the point is in between. So from here to here, is my cursor visible? So from here to here, in between any point, if you take the probability that x is.
The screen is not visible, sir.
Is it this one?
No, sir.
Now only it is seen.
It is visible, sir.
Cursor is so small. Yeah.
Okay, let me change that cursor. Now?
Yes, it's fine, sir.
Fine, sir.
So if my CDF is like this, something like this steps. From here to here, in between any point, if I take it any point, the probability that X taking that point will be 0. So you can prove it from by taking this logic itself. So CDF logic itself, A less than X less than B. So you take this point, you take this point. So fx of this point and fx of this point will be same. So the probability lying in between will be 0. So this minus this will be 0. And whatever the value you take in between, that will always be 0. And if there is a jump, if this is X is equals to 1, so then the probability that X takes value 1 is the length of the jump.
Okay, sir. So in case of mixture graph, in that case, the probability that X is specifically taking value, any value it is taking, which is like, can you draw a graph of mixture graph?
Let me take a graph of mixture. Let me see if there is any graph like that. Okay, let me take that. So let us take like this.
It's available on page 15. A mixture graph is available on page 15, 1.5.
Acha, page 15.
Yeah, here it is. Yeah.
So option B.
Yeah, in this case, the probability of X taking value 2 will be 0, but probability that X is taking value 0 will be 0.5, right?
So probability of X taking value 2 is 0, correct. And what is the other thing?
Probability that X is equal to the 0 will be 0.5.
X is equals to 0 will be equals to the jump height. If there is jump at any point, that means the probability that X taking that point will be equal to the jump, length of the jump. Whether it is mixture or discrete. In both the cases, if there is a jump, then the jump length will be equal to the probability of X taking that value.
And between value will be 0.
And in continuous part, whatever the point you take, that will be 0.
Okay, in discrete, this is also continuous. I mean, the straight path is a continuous path.
This
we can consider that.
This is continuous path. So that means if you see X takes 0 with probability 0.5, and next becomes continuous graph. From 0 to 6, from 0 to 5, X is taking values. X can take any value in between 0 to 5. So that is what this represents.
In the above option, like option number A, 1 to 2 is continuous. Can we say this in option A?
So option A, 0 to...
B, question, option B. I thought it's option A. Option B, 1 to 2 is continuous path and everything will be 0 in between that part.
So this is continuous path with same probabilities. There is no change in probability also. X cannot take those values at all.
Okay, the values it will take is 1, 2, and 3, 4 like this.
So here X can take any value in between these two. So if there are only horizontal lines, then only X cannot take any value on that horizontal lines. If the lines are like this, then X can take any value in between these two lines, these 2 points.
But the exact value will be 0, no? 4 point, like I have taken 2.
Yeah. So exactly it cannot take. The probability that X takes this point is 0, but my point is X can take that value
in interval.
Okay. So this value X can take. X is a possible value, but probability of X taking that value is 0. Exactly 0.
Okay.
Actually, it's not 0. It's very, very
precision will be very 0. Like 0.000. So we will consider it 0.
Correct. So there is some small chance of occurring this value, but it is very
precise that
less.
We can consider it 0.
It is 0. Correct. So out of all the possible values, so this is very less. 1 by some infinite. It is more like that. So it will be more of tending to 0, but not 0.
Okay, sir. Thank you.
May I ask a question?
Thank you.
In the previous form distribution, we said P X is equal to 4 probability x is equal to 4.5 is 0. But if we were to find out the CDF, that we can find, right?
CDF is different, probabilities is different.
Only the probability at that particular point is 0, but CDF would be whatever it is, right? Which would most probably be the CDF for 4.
So CDF for 4.
It's no, at 4. CDF at 4.5 would be the same as CDF for 4.
Correct. You are talking about option B, right?
No, I'm talking about the previous distribution, the uniform distribution that we had from 1 to 6.
Throwing a die.
Yeah. In that we said probability that x is 4.5 is 0. But the fx would be at 4.5 would be
fx 4.5 would be, it is actually, so write it through the basics.
1, 2, 3, 4,
this is
right?
actually x less than or equals to 4.5.
Yes.
So x can take 1.
Yes.
X can take 2.
Yes.
Like this, x can take 3.
So it's almost, it's the same as fx of 4.
So 4. This is same as fx of 4. Yeah. And this is same as fx of 4.1.
Yes.
So any value less than 5.
Up to 5,
yeah.
Less than 5.
Any value less than 5. Only 4 values are possible.
Okay.
So that is
basically this is interval, right? This is interval. So
this is interval.
So irrespective of whether the variable is discrete or continuous, wherever we have a continuous part of the function, that probability at a particular point will always be 0, right?
Correct.
And the minute it becomes discontinuous in a discrete variable, then it will have a value.
When the function is having a jump, right?
Yeah, so it would be discontinuous.
Take that point.
It would
take the jump point.
Which would be discontinuous at that point, right?
Correct.
Yeah.
So it will be discontinuous. If there is a jump like this, just look at the height of the jump or the length of the jump. So that will be equal to the probability of x taking value 4.
This would only be in case of a discrete distribution or a mixed distribution, right?
Even mixed also. Even in mixed cases.
Yes, but not in a continuous one.
In continuous, there will not be any jumps, right?
Yes.
So only in mixed and discrete cases, you will have jump.
We will have this.
Okay. And wherever there is jump, then there is a possibility of x taking that value. So there is a probability that x takes that value, and that will be equal to the length, height of the jump or the length of the jump.
Right.
Okay.
Yes. Thank you.
Okay. Let us look at PDF then. After looking at PDF, we will try to understand the difference between CDF and PDF. So CDF is more of it gives us the distribution, how my random variables are distributed, or is my random variable is continuous or discrete, or x is taking some value with probability this, or x is continuous. Like this it will give us. But probability density function is completely a different thing. So what is this probability density function? Even this is also a function, mind it. So even this is also a function. And likewise, we have seen in our discrete case, there is something called probability mass function. Even though we have seen CDF, but starting we have seen PMF, which is probability mass function. So there we have seen mass. Okay. So that means if it is discrete, each of the random variable, so if x is discrete, then x takes finite discrete values, something like 1, 2, 3, 4, like this. So if it is discrete, x taking value 1 has some mass. Mass means probability. So it has some probability. X taking value 2, it has some probability. X taking value 3, it has some probability. So like this. For each and every possible value, there is some probability associated or some mass associated to that value. So that is called probability mass function. That is what we will represent. And in the same way, in continuous case, we have to say something, right, about like this probabilities of, so whether x takes, so if I say x is taking values in between 0 and 1. So any value in between 0 and 1. But I just wanted, how do I know that x is taking values from 0 to 0.5 or more than x is taking values from 0.5 to 1? So how do I represent at which value x taking some value has more chances? How do I represent? So in discrete case, if I say probability of x being 1, it is 1 by 4, it is 1 by 4, it is 1 by 8, and this is 3 by 8. So if I say it like this, by looking at the probabilities, by looking at the mass, so this has 1 by 4 mass, 1 by 4 mass, 1 by 8 mass, and this has more mass, more probability. So by looking at this, we can say that x taking value 4 has higher chances in discrete case. Can I do something similar for continuous case? The answer is yes. So by looking at the probability density function, we can say that in a, even though it is continuous random variable, so even though it is continuous, when I look at the PDF probability density function, which is denoted as fx of x, and for what value of x this PDF is highest. So if it has high density, then the value, then the random variable x taking that value has higher chances, higher probabilities. So probability density function is same as probability mass function in discrete case. And how do we define this probability density function is, just now we have seen the CDF, a continuous random variable x, if it has some CDF fx of x, is said to have a PDF fx of x small f. So this is small f. For all x naught, so here also there is no some change. So this is not, this is only x. And there will not be this. Okay. So for all x naught, fx of x naught, if I integrate it from minus infinite to x naught, and inside there is some function dx. So if I am getting fx of x naught to be equal to this particular fx of x is called the PDF. Okay, it's just the integration of CDF.
Sir, 1 second.
Okay, so in discrete case, if you understand discrete case correctly, so if I wanted to find fx of x, what I will do in discrete case, it will be like I will sum over all the values, all the possible values of x belong to y belongs to tx and y is less than x. So I will sum over all the probabilities. Correct? We will sum all the probabilities in discrete case. What we are doing, we are summing the probability mass functions to get the CDF. So this is CDF and this is PMF, probability mass functions. So in order to get the CDF, what we are doing is we are adding up the PMFs, probability mass functions. It is discrete, so we can add. If it is continuous, so continuous or integration is nothing but continuous summation. So even in continuous case, fx of x is something like summation at particular y less than x, all the probabilities of x being y. So we will add all the values which are less than x, and these are continuous values. So each and every possible, there are infinite possible cases. So this particular summation, if it is continuous, we will write it as integration, and it will start from minus infinite to this x, and this probability mass function, now we call it as probability density function. That's it. The change is here. Instead of writing this, if we write this in continuous case, that will be very much equal to 0. So that is why we change it to density function. So this particular density means, So what is the physical meaning of density? What do you know about how do we define density?
More.
Mass by
Mass
volume.
per
Mass
unit
upon
volume.
volume.
Mass by unit volume, right? So here what we do is mass by unit length. So this mass is actually probability mass function. So we will add within that length, within that interval, we will add all the probabilities of that region divided by length. It will give me the density. So because I have very less masses for each and every possible value, so that is why instead of looking individual masses, I will look at mass by some unit length or probability by unit length. So mass, if you are confused, it is something like probability by unit length. Okay, this is called probability density function. Density. So probability density. Probability density is probability per unit length. Probability density means probability per unit length. Okay, per unit length.
It's like finding probability, average probability in a I mean in
In the
a
interval,
area,
in that region.
in that region, yeah, the average probability.
And yeah, this question is pretty much important. Instead of having one, why are we having two things? Why should we confuse ourselves? Just learn CDF, that's it, enough, right? Why do we need this PDF and why we are studying this probability density function separately?
Continuous variables, that's why.
Yeah, continuous variables only. My question is, why do we need probability density function? CDF is enough, right? For distribution, CDF alone can sufficient. If I give you the CDF, you can give me the distribution of that particular random variable X. And what's the special to study PDF also?
We get to know which values of are more likely to be common.
Likely to occur.
More probable, yes. More
Correct.
probable.
See, when we
Sir,
see this, please go.
So I think like when we draw any heat wave like graph, in that case, its PDF is more way simpler for us to find the probability than CDF. I mean, if we have if we have any heat wave graph or anything like we are not in a situation to draw a line of a continuous, then we can go for the PDF one. Is it?
Okay.
Yeah.
So anything, if we are unable to draw the CDF or complicated CDF is there, then we can differentiate that particular function and go for PDF. Is it?
Yes, sir. Yes, sir. Like in the heat wave graphs, like there we can find the PDFs easily.
Yeah. Correct. And if I wanted to represent in the graph, that will be easier. So now, what is the connection between CDF and PDF is this. This will be the connection.
Kind of a scatter plot type, I mean.
No. I'm just taking some random variable, graph of random variable. Okay. So you see, let's suppose say this is a curve, and this curve is representing fx of x. And if this is fx of x, then the area under this curve, so if I say this has x naught, now the area under this curve will be equal to fx of x. Okay, PDF is actually the derivative of CDF for the area under. If I know the PDF function fx of x, and if I can be able to draw that fx of x, the area under the curve will give me the CDF. Okay, this is CDF and this is PDF. And PDF is nothing but PDF is derivative of CDF. Okay, so if I integrate CDF, if I integrate PDF, I will get CDF, or if I derivate CDF, I will get PDF. So PDF is actually equal to the derivative of CDF, and this is how the connection between CDF and PDF is. If I know the PDF, area under the curve less than some x naught will give me the CDF. Okay.
So would the CDF be described as a function of x? Like we have normal functions of x?
CDF?
I mean, to find its derivative, the CDF's derivative, would the CDF be written as a normal function of x, the way we have?
Within that interval.
Yeah.
Okay. So yeah, our question is why we should study PDF is because one major thing is by looking at the curve or curves of CDFs, higher the CDF, it doesn't mean higher the chance of taking that particular value. It doesn't imply. So CDF actually gives us the distribution only. Again, we have to find which random variable, which value has higher probabilities and everything. But this PDF will give directly that if the PDF is higher, if I have higher PDF, then there is higher chance that x lies there. X lies very nearer to that value x. So this is that is why we study PDF. If we have PDF, we can easily guess what the values x can take, which has higher probabilities. But in CDF, we cannot do that. So that is why we should study PDF also equally. And yeah, I have already
any
discussed.
practical examples or any practical like
practical examples are like
we can relate easily.
Can I refer to a question, sir, in the practice assignment? Question
if there is question that
it is related to this only. Practice assignment 4, question number 2.
Question number 2. Which of the following statements are true for a continuous random variable with PDF of x? Is that the question? Okay, let me give you an example, simple example. So you all know cricket, right? So in cricket, there will be bowlers, if you remember. Okay, and each bowler will have a different average bowling speed. Right, Bumrah might have something around 145 plus. Maybe Bhuvneshwar might have something around 137 or such, and maybe Ashwin may have something around 98 or something. So how are we getting these averages?
Based on their previous record.
Average bowling speed. So how are we getting this? Firstly, tell me average bowling speed. If I say there is a person P and his average bowling speed of each ball is a value represents a random. So x1 represents the speed of ball 1. So the first ball he bowl, whatever the speed comes, that will be taken by this random variable x1. So x1 will be a continuous random variable. Agree?
Yes, sir. Yes, sir.
Similarly, x2 also the speed of ball 2. Okay, like this, if we have some 6 balls he bowled an over, the speed of ball 6. Right? So now this particular x1 to x6 are random variables. Agree? And where will I expect this x1 and x2 and x6 be? So what will be my expectations? So if I say the average speed of this bowler P is something around 105 kmph. Okay, this is his average speed. So where will I expect or the what values of x1 will I expect? Can I expect something like 60, 70, 80? Or will I expect somewhere around 100, 101, 110? Or will I expect something around 130, 140, 145?
Sir, around 105.
Around 105.
Yes, sir.
Because his
This is
mean.
average.
So that is his average and his mean is 105. And we know that this particular, whatever we are talking about, is actually follows a normal distribution. So this bowler P bowling at a speed of 105 is very common. And he might bowl some slower balls which may be 80, 70 or maybe below 70 also, but they are called the probability of this bowler bowling. Yeah, the probability that this bowler P bowling at an speed of 70 or 80, it has very less chance. So once in 300 balls or 250 balls, he might bowl one slow ball. So that is very, very less chance. And bowling around 100 to 110, it might vary. And this 100 to 110 has very high chance. And again, bowling at a speed of 130, 135, 140, it's not very common to him. So he might bowl like, he may or may not bowl, that is another question. If he can bowl, again, once in 300 or 400 balls, if he is running from very far, and if he had that accuracy, he might bowl 130. But definitely he can't bowl more than 180 or something. So if I draw the density function of this particular thing, so all are possible values. So from 60 or from 0 to, so even he can bowl, he may not bowl at all. And even he can bowl with 1 km per hour also, he just simply throw it. So there is a chance of ball throwing at 1 km per hour. So all these are possible. And at 105, as his average is at 105, so a huge chance of bowling at 105. So it has very huge chance. And from there, it will be like this. And it will be like this. So this particular function is probability density function. So there is very high chances. So you see this function is at peaks here compared to here. So this has very high chance. So he within 100 to 110, there is very, very high chance of bowling at that particular speed. So the probability, if you compute the area under this curve, will give you the probability between 100 to 110. So that is nothing but fx of 110 minus fx of 100. Okay, fx of 110 is this whole area. And fx of 100 is this area. So if I subtract red region from blue region, I will get this region. So this is fx of 110 minus fx of 100 will give you the probability that the particular person P bowls a ball with a speed in between 100 to 110. And from the density function, you can see that area under this curve, directly you can see that there is a high chance of person bowling within 100 to 110.
Sir, you said that this variable is following a normal distribution. Is there a way to predict which variable will follow which distribution? Is it can we predict that, or we just have to look at the data and find out?
Definitely, it depends on the data only. So it's called fitting. Okay. So when you see the data, you try to fit we will try to develop a model based on that data. Looking at the data, we will try to build some distribution. So this might follow this distribution, or this might follow this one. We will try to put that or embed that distribution into this data and find the errors, and we will do. If the error is very huge, then that particular distribution will not fit correctly. So we have to look out for a good distribution, a different distribution. So that, like, looking at the data only, we can fix the distribution.
Okay. We have to analyze the data to find the distribution.
Yeah.
We cannot predict that this particular data will follow this distribution only.
No. You can predict, but after seeing the data, what happens is, looking at the errors, you have to modify your distribution. Okay. So we will try to modify. Okay. That is what we are going to learn in week 7, week 8. When the actual statistics starts, now you will see the data and how to fit the data, how to estimate our parameters. So how to come up with a distribution by looking at the data. So which distribution fits, or what should be the parameter of the distribution in order to fit this particular data. So these all things we will study in week 8, week 9. So these are called estimation of parameters. So each and every distribution will have few parameters. We will try to estimate those parameters by looking at the data. We're looking at some 10-20 set of data points. We will try to predict. That will be more interesting. Okay, for that we should understand what are these distributions, or some standard distributions first of all. Okay, what is if I have given you this probability density function curve, what will the area under this curve represent? So these all things you should know prior. Okay, before studying that, you should know this. So that is why we are dealing this. Okay, so this is PDF. Area under the PDF will give you the CDF. Okay,
so
and this is the example.
So this area will have a certain probability, right? I mean,
yeah, those are the properties of PDF we will study. So what should be the area under this curve?
If probability is 1.
If this is probability density function, so the area under this curve will give me from -infinity to +infinity. And as I said, the area under this curve will give the probabilities in that region. So from -infinity to +infinity, if I add all the probabilities, I should get 1. So that is the first foremost property of this probability density function. Okay, here they have given examples also. So you can see the examples here. So if this is the CDF like this, a straight line which has some slope, then this particular CDF or the random variable will be uniform between that particular interval. So it has a straight line from 0 to 5, right? From 0 to 5, it has a straight line with some slope. So therefore, it will be uniform from 0 to 5. So if I draw the PDF, it has equal chances of X taking values between 0 to 5. And what should be the height of this straight line?
1/5.
1/5. Because if I compute the area under this curve, it is a rectangle and this length is 5, and the area under this curve should be equal to 1. As I said now, PDF curve ka area under the PDF curve should be equal to 1. So if this is X, 5 times X should be 1. So X should be 1/5. So height should be 1/5. Similarly, there is one more example. Even here also, you see it is a straight line from 0 to 0.5. 0.5. It is a straight line and it is 1 and 0. So even in this case also, it will be uniform between 0 to 0.5. 0 to 0.5. And the length, now the length is only 0.5. Therefore, the height should be 2. Then the area will be equal to 2 times 0.5, which is 1. Okay, so this is CDF. CDFs are always non-decreasing curves, but PDFs can be anything. So this is a rectangle, some one open rectangle. The above example PDF you see, this is something like a curve. Okay, this is called normal curve, and it might increase as well as it might decrease. Okay, fx of x can increase, decrease, can stay, can be constant like this. Okay, fx of x can be anything, but capital fx of x, which is CDF, will always be non-decreasing. So either it will stay constant or it will increase. There is no decreasing in CDFs. By looking at the graphs also we can see. And also area under this curves of CDF will not give you 1. So that will be infinite. Once it reaches 1, that will go to infinite. So there is nothing, it will represent nothing. Area under CDF will represent nothing. But area under this PDF will give us the probabilities. Okay. So what they have written is the same thing. The above figure is for the uniform distribution. The image on the left hand side is uniform 0 to 5. So uniform 0 to 5 means x taking any value between 0 to 5 has equal probability. Okay. So it has equal probability. So the density of each and every value will be 1 by 5. So from here fx of 2 is 1 by 5. Fx of 4 is also 1 by 5, like this. So the density that x taking value 2 and the surrounding is 1 by 5. Similarly, x taking value 4 and around the surrounding is 1 by 5. Like this. So it is uniform. Similarly, this is uniform between, this graph is uniform between 0 to half. So x taking values between 0 to half, x can take any value between 0 to half with equal probabilities. Okay. So, and also they have given CDFs and PDFs of exponential and normal. See, this is the PDF of normal distribution. Just now I have shown PDF of normal distribution. It will be like this. So when you see curves like this, they are called normal curves. It will increase for some time and it will take turn and it will decrease and it will eventually go to 0. So like this, if you see these kind of curves, this represents normal curves. And the CDF of normal curve will be like this. It is not a straight line. It will be like bend and bend here. And the left side is CDF of an exponential function. So exponential function will be like this CDF. And the PDF will be like this. So the probability that x taking larger and larger values will become 0. Okay, probability that x taking values nearer to 0 will have high chances in exponential distribution. 0 and surroundings will have high chances than compared to the probability that x taking larger and larger values. Okay, so these are PDF and CDFs of exponential and normal. And yeah, this is very important. Some properties of PDF. So just now by looking at the PDF only we can say whatever the curve I drew till now, every curve are above x-axis only. So there is no fx of x such that it is below x-axis. So that means fx of x. So when I say f small f, I am referring to small f. So f of x will always be greater than or equal to 0 for all x. So the curves will always be on the positive side of what we say above x-axis only. The curves will always be on the above x-axis. It will not go below x-axis. So fx of x will always be greater than or equal to 0. This is first condition. And the second condition is if I integrate from minus infinite to infinite, fx of dx, this is actually area under the curve fx of x. So it should be equal to 1. And this density function fx of x is a piecewise continuous. What do we mean by piecewise continuous?
At every point.
At every point. Any other answer?
Interval.
So till now what we have seen is, we have seen the PDFs of only continuous random variables. We haven't seen the PDFs of mixed random variables. Did we? No, right? Have we seen the PDF of mixed random? Mixed, I mean discrete and continuous.
No, sir.
No, right?
No,
if
sir.
the CDF is like this, the 0, 1, and 2, and this is 0.2. Okay, let me draw big.
One such question was based on such a diagram.
Let me take simple examples. They will be little difficult, I hope. So this is 0.2 and let us say this is 0.3. Okay. Now in these cases, probability that x taking value 0, probability that x taking value 1, it has some probabilities, and there is some uniform between 1 to 2. Okay. If I draw the PDF of this curve, I try to draw the PDF. So at 0, this is 0.2, and then from 0 to 1, the probability is 0. It will be like this. It will be like this till 1, and at 1 it is 0.3, and from 1 to 2 it is uniform. So this, and uniform means this is uniform, and I have already got 0.5. I'm left with only 0.5 probability. So open till 2 and 0 again, and on the left side also it is 0. So
Could
you see,
repeat this. At 1 it is how much?
At 1 it is 0.3, right?
Yes. And here why are we taking it lower?
No, this is open. It will not take, but the very next value of 1, the curve is starting. So that is what it represents, the open circle. Open circle line means that particular point is not included. The very next point, from there it is starting. The line is starting from the very next point. So here also 1 is 0.3.
Yes.
But this particular open circle means it is not taking value at 1, but the very next point will take values here. The 1 is not being included.
What value is it taking?
What value is it taking? We have to find. So 0.2, this is length of 1. It will take 0.5, right?
0.5, yes.
This should be more. This should be something like here.
Yeah, that is why I didn't understand why it was lower.
Okay. So it will be like this. And 2 included, maybe. Okay. So this is what the PDF will look like. And this is very clumsy PDF, if you see. Okay. Sometimes it is continuous. Sometimes it is just the points. Again, it is continuous. So piecewise continuous means, so if I write, so in this interval, this is continuous. 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 Okay. So something like if I write fx of x, separately. So my fx of x will be 0.2 when x is equals to 0, 0.3 when x is equals to 1, and 0.5 when x is in between 1 to 2. Okay. Now you see, this is one piece. So x is equals to 0 is one piece, x is equals to 1 is another piece, and this interval is another piece. So they are piecewise continuous. This is continuous, this is continuous, and this is continuous. This will be continuous. So if I break my function into pieces, pieces means in some intervals, those intervals are definitely continuous. Okay, there is no breakage inside it. If there is breakage, that means there is some probability that that particular random variable is taking, and that will become another piece that will not be included here. So these are pieces, piece 1, piece 2, piece 3. Okay, so these three pieces are continuous. So that is what it means. Piecewise continuous means within the pieces they are continuous. And yeah, this is important. These are the three properties, important properties. Definitely, whatever the value I take, my density function should be greater than or equals to 0, because it is density. Okay, densities will not be less than 0. So it will always be greater than 0. And if I integrate from whole from minus infinity to plus infinite, if I integrate this density function, I should get 1. And this f of x should be piecewise continuous. These are the three conditions. If it is satisfied, then it is a valid density function. We call it as a valid density function.
At x equal to 0, it is 0.2, and at 1, it is 0.3. So how can we say it is continuous? At 0, it is just a point. At 1 also, it is just a
See,
point.
at single point, that is only the domain. Okay, if you treat it as the domain, there is only one point, and that point has some value. So we will say it is continuous. So these cases we will assume to be continuous. Okay, it's kind of neglecting the issue that it is a single point. Okay. Yeah. So these are the three important properties of PDF, and there is another thing called support of a random variable. So this is also important, but support is not a new thing. Support is actually same as range in discrete case. So you see, when you read the statement itself, we will understand it is defined as the points, set of all points where the density function is strictly greater than 0. So that means for any random variable x, if I consider all the set of small x such that fx of x is greater than 0, this will be giving me some interval or some set of points, and that set of points actually refers to it is actually the interval in which x can fall with positive probabilities. Here it is given, you can read this. So support of x contains intervals, and that intervals refers x will only take values within those intervals. So that is called support. Support means range. So if you treat it as a range, the possible values of x are the range. So here also the possible values x can take is the support. So when do we know that x takes this possible value? When the density is greater than 0 at that particular point. So all that points having density greater than 0 is called the support. Okay. So here, previous examples, if you look at here. So you see in this PDF, below 0 and above 5, our fx of x is 0. Fx of x is 0 for x being less than 0 and x being or x being greater than 5. So in these two cases, fx of x is 0. But fx of x takes some value 1 by 5, so which is greater than 0. In the interval, x can be anything between 0 to 5. So x can take any value between 0 to 5. And whatever the value it takes, my density function value is 1 by 5, which is greater than 0. So therefore, my support of x will be this interval. So support of x, this particular x will be interval 0 to 5. Okay. Same as range. So x can take any value from 0 to 5 with some positive probabilities. So that is what support of x means. And what else? For any event A define. Yeah, this thing I already stated above. So if I define any event, like this between 100 to 110. So if I ask you to find the probability that 100 less than x less than 110, what you have to do is you have to integrate along that event, which is from 100 to 110, fx of x dx. So similarly, probability of, if I generalize it, for any event, you have to integrate along event fx of x dx. So if you integrate, you will get the probability of that particular event. Here the event is I have taken between 100 to 110. X is taking values between 100 to 110. You can define your event. So whatever the event is, you have to integrate along that event only, along that event limits only. That is about that thing. And yeah, there are some examples. We will try to do 1 or 2, and we will go to solving problems. Okay, sorry, I have to discuss few common distributions also, right? Okay, I will deal common distributions first. We have only 2 or 3. Yeah. First distribution is uniform distribution. So when do we say continuous random variable is uniformly distributed? So this is how it will be. If the PDF is like this, so just now we have seen the PDF is like this and the CDF is like this. The continuous random variable x is said to be uniform in the interval AB. So this is A and this is B. If it has a flat PDF, so like this flat PDF. And as I said, a straight line with some positive slope. If it has a CDF like this and also PDF like this, we say that particular random variable x is uniform between AB, and we denote it like this. X follows uniform interval A comma B. Okay. Or simply we say uniform A comma B. So if it is open brackets, that means it is an interval. If it is closed, if I say curvy brackets or third brackets, AB, so that means discrete. So here x is discrete, where x is uniform between A and B. So the probability of x taking value A and probability of x taking value B are equal to half. So if it is the third bracket or the curvy brackets, then it represents discrete case. When it is open brackets like this, then that is an interval and x is continuous from A to B. So x can take any value in between A to B. Okay, understand the difference. This is continuous. And now we are dealing with this case. Okay, for this thing, the PDF of x is given by 1 by B minus A. So it is very simple to look. So the area under the curve should be equal to 1. The length of this line is B minus A. And the area under this curve should be equal to 1. So if I say this is x, so x times B minus A should be equals to 1. So x should be equals to 1 by B minus A. So the PDF value should be equal to 1 by B minus A for all x between A to B. and for the rest of the cases it is 0. So that is what the PDF function will be. And the CDF of x is actually we have to integrate from minus infinite to a. You just simply integrate. So you start from fx of x is nothing but minus infinite to plus infinite fx of x dx. So this minus infinite to plus infinite, I will split from minus infinite to a, and from a to x, a to b. Oh, sorry. What is this?
Here, in between term should be a to b, sir.
A to b, right?
Yes,
if
sir.
it is a to b,
this first term, I think it should be 0 dx. First term, it should be 0 dx. No?
It is a to x, sir.
Okay, a to x.
It should be a to b, sir. A to b.
Oh, sorry. So this is minus infinite to x only. So we are trying to find fx of x, right? So minus infinite to x, fx of x dx. What is happening here? I don't think this term will come at all.
The second one is integral 1 dx is x. And if you substitute the limits, it is going to be x minus a. That's why we are getting x minus a by b.
It should be 0. First integral 1 minus b by a is this. So 1 minus b minus a, it should be 0, sir.
It should be 0. This should be 0. This should also be 0. Correct. So see how we defined fx of x. It is actually from minus infinite to x, fx of x dx. Correct. This is what the integration is. So when x is less than a, then it is simply 0. So this will be 0. When x is in between 0 to a, okay. So you see here, when x is less than or equals to a, it is simply 0. So when x is in between 0 to in between a to b, now this is how it will be. So this term also will not come. So minus infinite to x. Now x is being in between a to b. So minus infinity to x, minus infinity to a, it is 0. And from a to infinite, it is 1 by b minus a of dx. So from if I split the limits, minus infinity to a, my fx of x is 0 dx, plus from a to x, it is 1 by b minus a dx. And this term will not come. And this is integral minus infinite to a, 0 dx will be 0. And this will be, if I integrate, it will be x by b minus a. Limits are x and a. So if we solve this, x by b minus a minus a by b minus a, we are going to get x minus a by b minus a. So this x minus a by b minus a, when do we get this? When x is in between a to b. Okay. So you can take a and b inclusive, or you can exclude it, because this is a continuous random variable. So even though if you exclude, it's fine. So x minus a by b minus a, when x is in between a to b. And when x is greater than b, so everything will be into this consideration. So when x is greater than b, so what happens? It will be like this. Something like this. Fx of x. So when x is greater than or equals to b, fx of x is integral minus infinite to x, fx of x dx, and this will be minus infinite to a, 0 dx, plus a to b 1 by b minus a dx, plus b to x 0 dx. Okay, 3 values. And this will be 0, this will go to 0, and this will become 1 So if you integrate this, this will become 1. Sorry, this will become 1. And this is 0 again. So the total value will be 1. So when x is greater than or equal to b, it will be equal to 1. So I don't know. If people are getting it's okay, fine. So in PDF, it is very difficult to understand. If you ask me to write it down, the 3 cases, I will write it down again in somewhere.
I am a little confused. X is equal to a. What is the value of the PDF?
Value of the PDF.
At x is equal to a.
So if it is closed, it will be 1 by b minus a.
Okay.
But at point a should be 1 by integral a to a, right?
Integral?
So it should be integral a to a, which will be 0, right? At a given particular point.
That is CDF.
That is CDF, right?
Okay, okay. I got confused. Sorry.
I am a little confused. At x is equal to a, what would be the value of the PDF?
PDF is 1 by b minus a. See, this is closed intervals, right?
Closed meaning a and b are included, right?
Yeah, a and b are included.
So at x is equal to a, what would be the PDF?
PDF value will be 1 by b minus a.
But we have written here in this range, x is less than equal to a would be 0.
See, if I substitute x is equals to a, it will give me 0, right? This is CDF, not the PDF value.
Okay.
CDF is this.
Okay.
Okay. Okay. Shall I write down the cases? All the 3 cases which we have discussed now? Yes, no. If no, I will just skip and we will go to...
I'm so sorry to again ask the same question. So what we are saying is this is actually CDF that you've written with these ranges, right?
These are
So
CDF.
then equal to z. But if I were to write the PDF of x is equal to a, then it would be 1 by b minus a.
This is the PDF.
Yeah, PDF would be 1 by b minus a at the point a.
Correct. So when x is equal
But
to
the
a,
CDF would be these ranges, right?
Okay. Let us try to do this then. So x is given to be uniform. See, this is closed interval minus 10 to plus 10. So this is continuous random variable where it is uniform between x can take any value between minus 10 to plus 10. Now we have to find these probabilities. So we will do this. Okay, we will do this, and this. First 3. So in order to do this, firstly we need to know the PDF. So once I said it is uniform, we know how to write the PDF. It is 1 by b minus a. So if it is a and b, so it is 1 by b minus a. 1 by 10 minus of minus 10. So this will be 1 by 20. Okay. So the PDF will be 1 by 20 when x is in between minus 10 to plus 10. And it will be 0 elsewhere. So now I have to find the probability that x is lying between minus 3 to 2. Okay, how do I find this? So this is an event and I have to integrate along this event minus 3 to 2, and my density function I know it is 1 by 20 dx. So if I compute this, x by 20, 2 minus 3, so this will be 2 by 20 minus 3 by 20.
1 by 4.
So it will be 5 by 20 and it will be equal to 1 by 4. So this is how you can find. And the next one is, there is something extra thing which is modulus. So if I have to find the probability that phi less than x mod x less than 7. So this is actually x can lie in between minus 5, okay, minus 5 greater than x greater than minus 7, or probability that 5 less than x less than 7. So you can see simply, right? So x can be taking values between 5 to 7, or x can take values between minus 7 and minus 5. Both the cases modulus will be in between 5 to 7. So I have to find this. The first thing is minus 7.
భాష రైట్ సైడ్ చూడంత పెద్ద మసీదు ఎలా ఉందో చూడు అసలు.
Okay. Okay. So this thing, and this is probability that 5 less than x less than 7. So from here you just compute this event is minus 7 to minus 5 1 by 20 dx plus 5 to 7. So this event is 5 to 7 1 by 20 dx. So if you compute, you will get the answer. Okay, so the answer will be somewhere around, this is
4 by
2 by 20 and 2 by 20. You will get 4 by 20 again. Okay, not again. This is 4 by 20 and this will be 1 by 5. Initially you got 1 by 4. So this is 1 by 5. And one more thing is we will try to do
2 by 20, sir. The first one.
First one is 2 by 20. Second one is 2 by 20, right? Even we have one more case.
Total it is 4 by 20.
Total it will be 4 by 20.
Sir, where should we find the material with all the workings?
With all the workings means?
That means you calculate some problem now.
These things, huh? Now what am I doing?
Yes.
This will I will upload in live session notes. See, when you open this live sessions tab, just come to the bottom of live session tab. There is something called live session notes.
Yes, but calculation are missing. Only the printed letters are there.
See, I didn't upload it yet. Once after this session, I will upload it. I will ask them to upload and they will upload. Okay.
Okay.
So yeah, how do we do this then?
Could I just ask a question? 1 second, if you could go back to the second one we had solved. Here, in the second part of it, that is the probability that x is greater than 5 but less than 7. We don't have is equal to, right?
See, in continuous case, I will tell you one thing. So in continuous case, probability that a less than or equals to x less than or equals to b is equals to probability that a less than x less than or equals to b.
Oh yes, because the probability at a particular point is 0. Okay. Sorry, I forgot that. Okay, thank you.
So all these probabilities are equal. So even though equality sign is there or not there, doesn't matter.
Okay.
Okay.
Yeah. Thank you.
So now this part is actually, it is lying in between 1 minus epsilon to 1 plus epsilon, something around 1. We are computing the probability density around 1. So this is integral 1 minus epsilon 1 plus epsilon 1 by 20 dx. So if I integrate this will be 1 plus epsilon divided by 20 minus 1 minus epsilon divided by 20. And we are going to get epsilon by 20. So something
2 epsilon by 20. 2 epsilon by 20.
Yeah,
2 epsilon by 20.
2 epsilon by 20.
Yeah.
Correct. So we are going to get epsilon by 10. Okay, this is the probability. Depending upon this epsilon value, how small it will be. So that will be the probability. So like this, you can compute the probabilities using the probability density function. So integrating the probability density function within the given event, you will get the probability. Okay. So this is about uniform. Uniform case, you can do it like this. There are much more examples in uniform.
Could you do the last one also? I think it's given some value, right?
X.
Which one? This one. It's a
Yeah, X is
condition.
greater than 7. Yeah, conditional.
Conditional. So how do we do this conditional? Just a second.
X is equal to 7. We have to subtract it, sir. We have to calculate for X is equal to 4.
So this is a conditional probability. So first write down the conditional probability into joint and divided by marginal. So something like these are two events, A given B. So it will be A intersection B. So X greater than 7 and X greater than 3 divided by probability that X is greater than 3. Right? So what will be the above event convert to? X
is greater than 7.
Correct. So X is greater than 7 divided by probability that X is greater than 3. So X is greater than 7. That means from 7 to infinite. The event is from 7 to infinite.
Yes.
Correct. So 7 to infinite fx of x dx divided by 3 to infinite fx of x dx. But this is not defined till infinite. So it is being restricted to 10. The maximum cap is 10. Okay. After 10, it will be 0. That's it.
Yeah.
So I can write this particular integral as 7 to 10 fx of x dx plus 10 to infinite 0 dx, and this fx of dx is also 1 by 20 in that interval 7 to 10 divided by 3 to 10 1 by 20 dx plus 10 to infinite 0 dx. So from 10 to infinite fx of x is 0. That is why I am splitting the intervals. So this and this will be 0. Ultimately we are left with this. So this is something like
easy
10 by 20 minus 7 by 20 divided by 10 by 20 minus 3 by 20. Okay.
Had it been less than, then we would have said from minus infinity to
7.
Whatever, 7. And since we don't have minus infinity, we would have started at minus 10.
Minus 10. Correct. So had it been like this, probability that x is being less than 3 given x is less than 7.
Yes.
Something like this.
Yes.
So then it will be like probability that x is less than 3, less than 7.
Yeah.
So everything is common. So the above event will convert to x is less
than 3. Yes.
X is less than 7. If you know directly the CDF, so CDF of this is simply fx of 3 divided by fx of 7. So if you don't know CDF, from PDF also we can do it like this, whatever you said.
Okay.
So minus infinity to 3 fx of x dx divided by minus infinity to 7 fx of x dx. Okay.
Yes.
And minus infinity to minus 10, it is 0. So we will include from minus 10 to 3.
Yes.
Minus 10 to 3, 1 by 20 dx divided by minus 10 to 7, 1 by 20 dx.
Right.
So this is 13 by 17.
Yes.
Okay. So you will get like this.
Yes.
And the procedure is same. Whatever we are doing, everything is same.
Yes.
But only the condition, the event, how they are defining the event is different. That's it.
Okay.
By looking at the event, you have to take the corresponding intervals, corresponding limits for the integral. Okay.
Yes. Thank you.
Yeah. So let's see the exponential function distribution. And exponential distribution will have PDF as like this. So fx of x will be equal to lambda times e to the power minus lambda x when x is greater than 0, and it will be 0 otherwise. And this lambda is called the rate parameter. So this is called the parameter of exponential distribution. Okay. So I say x follows exponential with rate lambda if I have PDF like this. So if my PDF is like this, then I say x is exponentially distributed with parameter lambda. and you can check for the conditions of PDF. This fx of x will be greater than or equals to 0, and the support of x is x greater than 0. So x greater than 0 only we have some density, some value for the density, and otherwise it is 0. The support will always be x greater than 0. And you check the second condition of property, second property, which is minus infinity to plus infinity fx of x dx should be equal to 1. So if we check that, it will be equal to 1. Therefore, we conclude this is a valid PMF. So in order to check whether the given PDF is valid or not, you just check for this condition mainly. This along with fx of x greater than or equal to 0. Okay, these two conditions will more or less, it will give you the third property, which is piecewise continuous. So if you are able to get this and this, the third property will always follow. So you don't need to check for, or you don't need to be like what if it is not continuous or like this. It will be piecewise continuous if you are able to get the integrations. So if you are performing integrations, that means the function is actually piecewise continuous itself. Okay, so mainly you have to check this too. So if any PDF, so I will call any function as a PDF if it satisfies these two conditions. So clearly these two conditions are satisfied by this PDF. So this is the PDF. This I can call it as a PDF, and this PDF is actually the PDF of an exponential distribution. Okay. So,
I'm a little confused here. How do we get this PDF? I mean, how do we know that when x is greater than 0, then that is the value, and otherwise it is 0?
How do we getting this? Is it?
Yes, yes.
This will.
Is it something we have to memorize, or we can?
No need to memorize. See, exponential distribution is actually coming from Poisson distribution. Okay.
Yes.
So if I had to go little outside our context, see, Poisson distributions are basically it depends on time. In Poisson processes, time is also a parameter, right? First success can occur at this time. So at time t1, my first success is occurring. At time t2, time t3, this is the third success. So the difference between, so the time between two successes will follow exponential.
Okay.
Okay. So this is a random variable.
Yes.
Okay. So this x1 taking x1. So the first success occurring at t1 is actually, it has some probability, and the second success occurring at t2. So second success can occur at any time, but second success occurring at this will be like x2 will be t2, and the difference between these two, x2 minus x1, will follow exponential.
Okay.
Okay. If this Poisson process has parameter lambda, okay, if I say this x follows Poisson lambda, so that means my success will occur at a rate of lambda per hour per hour.
Yes.
Correct.
Yes.
So lambda successes can happen within an hour or within the given time.
Yes.
Okay. So in that lambdas, this might be your first success at this particular time, and this might be the second success, third success, and these successes are independent to each other. Okay. So it will not depend. So x2 time occurrence of x2 success will not depend on x1. Okay. Or simply you see, if you are running a shop, some retail shop, so customers will arrive to your shop, right?
Right, at a particular rate.
At a particular rate, and first customer, let's say first customer is arriving to your shop at 9 a.m.
Right.
So the second customer arriving at 9:20 is independent of when the first customer comes, right? So once the first customer comes into your shop, you will note down the time, and that particular time will be given to the first random variable, first success. Okay, like this. If you give like this, the time difference between two Poisson successes will follow exponential.
Okay.
Okay, from there it will come. So by taking Poisson distributions and looking at this, so x2 we know x2 is actually follow Poisson lambda, x1 we know Poisson lambda. Okay, and the difference between Poissons will give you exponential. So while taking moment generating functions, we can prove this. Okay, this moment generating functions will come in week 7 or such.
Okay.
Okay, but this lambda and lambda, this lambda comes from there.
Okay.
From Poisson.
Okay. And this exponential function has this value lambda into e to power minus lambda x.
If so, till week 4, maybe you just believe me that
this is how it is.
This is how it is.
Yeah, so I take it as a taken. It's a given that this is how it is.
Parameter for the exponential and the Poisson is the same in the example which you just discussed. Lambda is same for exponential and Poisson in this case.
Yes.
Okay.
Sir, would you please discuss activity 4.2, activity question 4.2?
4.2?
Question, sorry, let me tell you the question.
Okay, let me just finish this.
Question, sir.
Okay, I will just finish this with normal. Normal is very, these are the PDFs and CDFs just now I have shown you. So if you integrate the PDF we have, you will get the CDF as like this. Exponential CDF will be like this. So try doing this. And the last one is you have normal distribution, I guess. Where is it? Yeah. So PDF of this normal distribution is also like this, will be like this. And the support will be the whole R. It will go from minus infinity to plus infinite. You try doing this. You try to integrate from minus infinity to plus infinity this particular expression. For this, you require integral e to the power minus x square dx. First, try doing this. How do you get integral e to the power minus x square? So e to the power minus x is very simple, but e to the power minus x square is slightly difficult. Once you are able to find this, then integrating this will be very easy. Is the proof given? Yeah, anyway, proof is given. Proof is also given. You can go through the proof if you didn't able to solve. So this will be the PDF. If PDF is like this, then the random variable will follow normal distribution. Okay. So one good thing about normal is you no need to find the expectation of normal distribution separately. Wherever the peak point is there, that will give you the expected value of that particular random variable. So that will be equal to mu. Okay. So fx of x takes maximum value at x is equals to mu, which is the expected value of that particular random variable x. So if I say x follows normal, so we say x follows normal. Normal will have two parameters, sigma and mu. So normal 30 comma 3. If I say like this, then the expected value of x is 30 and the variance of x is 3. So the parameters itself will give us the first moment and the second moment. So did we discuss moments? No, right? First moment.
Sir, it was discussed in the lecture, sir.
Moment.
Hello, sir. Hello.
Yes, sir. Like the videos which was for week.
Okay.
Sir, sorry to interrupt. In last session, the YouTube link was available. Only 15-second video was there, and this session have no YouTube link provided in our calendar. So kindly correct this.
No YouTube link provided, is it?
Yeah, I checked.
Yes, no, sir. YouTube link is there.
Link is there.
Sorry.
I can see the YouTube link. Yeah, I can see the YouTube link.
Can I just post it here?
So wait, let me post it. Sir.
Yeah, sure.
I am just opening it. Yeah, already Ravikant.
And the session which was in 30th of September, that have only a 15-second video on this YouTube
that
link.
Was there has been some error and live stream got stopped somehow.
Okay. How can we got this video?
I am very sorry, you cannot get that video.
Okay.
But we will try to upload the PDF of that particular video lecture. That particular lecture. Okay. So we will try not to repeat these mistakes in future. That is what I can say to you right now.
Okay, thank you.
Okay.
Could you discuss that activity question?
Let's go to activity question now. So normal thing, you just go and watch the lecture. It is, I don't think any explanation required here. So let us solve that activity question. 4.2.
Question number 4, sir.
Just a second, let me open. Question number 4. Calculate probability that x is equals to 8 given x is greater than or equals to 4. That is the
yes, sir. When I calculate x greater than or equal to 4, it means probability of 1 minus probability of x less than 8.
So,
sir, but I am not able to get the right answer.
Let us try now. Okay, I will write the question here.
Yes.
So CDF is given like this. So everyone who are in this session, please try solving this question. So CDF is given to us, which is equal to, can someone read out? It was like very, I have to toggle between tabs. So 0.29, 0.68, 0.88. Okay, it is 0. 0.29.
If x is less than 0, so 0.29 if x like x is greater than
0.68 for 1x 1 less than to 4. 0.88 for 4 to 8. Then 1 for greater than 8.
Okay, this is the question given, and we wanted to find probability that x is equals to 8 given x is greater than or equals to 4. This is what the question, right? Right. So we will just like we have seen now. So this is the conditional distribution. So just convert it into probability that x is equals to 8 and x is being greater than or equals to 4 divided by
probability of x greater than or equal to 4.
Now, how can I convert this event? What is the combined event?
Probability of x equal to 8. X equal to 8 is 0.12, sir.
So probability that x is equals to 8 divided by probability that x being greater than or equals to 4. Right? What is x greater than or equals to 4? This is a discrete distribution, right?
Yeah. Yes, sir.
Yes, sir. So 0.88.
So probability that
x greater than or equal to 4.
So just correct me if I am going wrong. Okay. So probability that x is equals to 1 will be 0.39.
39.
This is 0.39. So x is taking value 4 is 0.2.
0.2. Yes.
And probability that x is taking value 8 is
0.12.
Okay. Yeah. Now what do we mean? So x can only take these 4 values, 4 discrete values, 0, 1, 4, 8. So what do we mean by probability that x is taking values greater than or equals to 4? It can take 4, x is equals to 8. Correct? So x is equals to 8 is 0.12 divided by probability that x is equals to 4 is 0.2 plus 0.12. This is something like 0.12 divided by 0.32. So it is 6 by 16, 3 by 8.
Sir, how you have written this second step, sir?
Which one? This one?
Yeah, this one. This one, yes.
See, probability that x taking values greater than or equals to 4. See, x can only take values 0, 1, 4, 8. Okay. This is x is taking values greater than or equals to 4. So what are the possible values of x can take? 4 and 8?
Yes, sir.
So probability that x is greater than or equals to 4, I can write it as probability that x can take 4 or means plus probability that x takes value 8. Correct? So the denominator I can write it like this.
Yes, sir.
And the numerator is this. Probability that x is equals to 8. So simply substitute the values. Probability that x is equals to 8 is 0.12 we have. And probability that x is equals to 4, 0.2 we have. So 0.12 divided by 0.2 plus 0.12. So we will get...
Sir, from where do you get the values, sir? P of x is equal to 4 is equal to 0.2 and P of x is equal to 8 is 0.12.
By looking at this CDF, right? The jumps, they are the jumps, right?
Yes, so sir. We have to subtract 0.68 from
0.29. 0.29. You will get probability that x is equals to 1.
So we can do one more way, 1 minus probability x is less than 4.
You can do that.
Sir, I have one confusion, sir, in step 2. One confusion in step 2. In step 1, you have written probability x equal to 8, comma, x greater than equal to 4. It should be the multiplication of probability x is equal to 8 and x greater than equal to 4.
No, that is joint events, right? Now I have to find probability that x is equals to 8 and probability that and the other event is x should be greater than or equals to 4.
मतलब इसमें in this both the conditions satisfy only.
So x is equals to 8 होना है as well as x should be greater than or equals to 4. So इन दोनों को combine किया तो what will it be? Combined event. So x 8 होना है as well as x should be greater than or equals to 4. Combinedly it will give me x should be 8, right? So it's the intersection.
It's like memory-less property, like it's memory-less property, like something. If x is greater than 4, then it should be.
Means it right, sir. Now.
Sir, it's like intersection.
It's an intersection thing. Intersection. X is taking 8 in the first event. X is 8. And x is greater than or equals to 4. So if I intersect it, common thing is x is equals to 8 only.
Yes, sir.
Okay. So it's like intersection. End is intersection. Okay. So this will be like probability.
Okay, now I got it, sir.
So yeah, one more problem I will do from just now what we have studied.
Just one thing. Here we said this was a function of a discrete variable, right? How would I know whether it's continuous? How would the continuous one look like generally?
Yeah, there will be some x terms. It depends on the value of x takes. So something like straight lines or curves.
Okay.
So straight lines and curves will have equations involving x, right?
Some sort of function
of
x.
These are actually some sort of function of x.
Okay.
If it is continuous.
Okay, that's how we know. Okay.
Let me give you one good example. If I say, let's say there are many examples, I guess, fx of x, something like there is some unknown constant c times what will I give is c by x minus 1 by, okay, let's not complicate it. C by x minus 1 when x is greater than 0 and 0 otherwise. And I said this fx of x is a valid PDF. How do I check? And okay, I said valid PDF. I just want the value of c. How do I find?
Integrate the first function.
PDF or CDF? PDF, yes.
PDF. This is PDF I have given.
Integrate the first function from 0 to infinity.
Yeah. So for let's use the properties. We are going to use the properties and find the values. So there are many tutorial questions on this, some practice assignment questions also, I hope. Even in graded one question is there. So what
Sir,
you have to do is
also we have to integrate, sir.
Huh? Even
If it is CDF, we need to integrate. Even if it is PDF also.
No. That is what I said. CDF, there is nothing called area under the curve. So area under the curve is nothing but integrating. So if you integrate the function, you will get the area under the curve.
Yes, sir.
So area under the curve of CDF, it represents nothing. It doesn't represent anything. So there is nothing.
So it is area under the curve is PDF.
If I find the area under the curve of a PDF
That
function,
gives CDF.
that gives me CDF,
yes,
and
sir,
also
yes.
it gives us the probabilities. Yeah.
Yes, sir. Area under the curve gives CDF.
Area under the curve of PDF gives the CDF.
Yes, sir. Thank you, sir.
Yeah. So I have to integrate from minus infinity to infinite fx of x, and as it is said that it is a valid PDF, this should be equal to 1. So from minus infinity to 0, it is 0. So I don't need to consider. I just have to consider from 0 to infinite, and in that 0 to infinite, fx of x is something like c by x minus 1 dx should be equal to 1. So what is the integral of 1 by x? Anyone?
Log x.
Minus 1 by x square.
Integral.
No, log mod x. Sorry, sir. Log
x.
Yeah. C log x.
So this will be c log x
minus x
minus x
from infinite to 0 should be equal to 1. So if I substitute infinite, it will go to infinite minus infinite. Yeah, this is what happens. Let's take x square. So that is not a valid PDF actually. For any value of c, it will not be a valid PDF.
C by x minus 1 also has to be greater than 0, right? Or greater than or equal to 0.
Yeah, c by x minus 1 is greater than. So this is an important condition. Yeah, c by x minus 1 should also x square. Now I made it x square. So this will be like if I integrate minus c by x minus x
even that minus x should not come, sir.
So this is why you shouldn't prepare questions then and there itself. Itna errors aata hai. These many errors you will get.
No, it should not be minus 1, I suppose, sir.
Now it will be. So within 0 to 3, if I restrict,
it's fine, sir. Yeah.
Then
it will infinity, the problem is coming.
So it will be 0 to 3. This will be 0 to 3.
Yes, sir.
So from here it will be just substitute the values minus c by 3 minus 3.
Again problems, sir.
Again problem.
That 0 is becoming a problem, sir.
Now 1.
1 to 3. Yes, sir.
Okay. So now you understand, right? How much time we will take to prepare one particular question.
Yes.
Yes, sir.
And sometime
so we spend more time to solve them.
Even after preparing, you will find an error in that question. Then how that it will be? So we will look for multiple times of review. Then also we will unable to spot this few things. We will be unable to spot. One thing is like this. So this should be greater than 0 first of all. If we miss this, and if we have given values which doesn't satisfy this condition, we are gone. So we have to give an add score, or we should remove that particular question, and something should be there. So from 1, okay. Now it will satisfy. Minus c by 1 minus 1 is equals to 1. So this should be equal to 1. So from here, if I solve, I can solve for c. So minus 3 plus c plus 1. Yeah. So from here you just solve it. I guess 2c by 3 is equals to 3. C will be equals to 9 by 2. So for 9 by 2 value, this particular PDF, this particular function can be a PDF. Okay. Just
this means we have to remember all of our integration now.
We will give you that integral things. No need to worry. We will give it as a
Because
hint.
I've forgotten all of it.
We will give it
Sir,
as a
but
hint.
formula we need to remember, no, sir?
No. We will give it as a hint. We will give something like this. So 1 by x power n dx will be minus
This
n
will
by
kind of.
sorry.
Okay. Actually, in fact,
X power minus n plus 1 by minus n plus 1.
X power
minus n plus 1.
So 1 minus n.
Yes, sir. X power 1 minus n.
X power 1 minus n. So we will give you like this. We will not give you the direct values, but we will in general give this. Okay.
Because that Poisson one, exponential one, the integration was not so easy. I don't remember it now.
If I don't know, I am supposed to show it now. We will show it while we are doing the revision session.
Okay.
We will give you a formula sheet. Okay. No need to mug up all the formulas. You no need to by heart what is the PDF of exponential function, what is the CDF of an exponential function.
Sir, even that also it's not required.
Not required. Even Markov inequality and Chebyshev's inequality we will provide you. Okay.
So, enough to understand the concept.
But you need to understand when to use Markov, when to use Chebyshev, at what places Markov is useful. What is that x mu sigma represents? That is what you have to find and substitute the values there.
Concept and application is enough.
Enough. No need to remember. I think I can show it. Anyway, we will be showing you, or anyway you are going to see it, right? So what all things you shouldn't memorize is this. Let me just open and then I will share it. I have some more confidential information, so that is why I couldn't.
That's okay.
Yeah, able to share everything.
Might be question, sir.
Like that. So let me just give me 2 more minutes. I have to just search.
Yeah, that's okay.
Yeah. This. Okay. Let me download this. Okay, now I'm ready. So, where am I? Okay. Where is this formula sheet? Yeah. So this is the sheet which we are going to provide you. Okay. So we will provide you the uniform, all the discrete random variables. So expected values also we will provide you. Okay. And the next page we will provide you with this continuous random variables with PDFs, CDFs, expected values and variances. And Markov's inequality we will provide you, Chebyshev's inequality we will provide you. So these are the informations we will provide you in the exam also.
Sir, we will find these notes in the live session notes, na?
Which notes? This particular session's notes, I will ask them to upload in the live session notes.
Yeah, I just saw actually previous live session notes were there. You can.
Is there, right? Yeah. There itself, this will also get uploaded.
The formula file will also be uploaded there.
Why formula file? The formula file you will get it in the exam.
Oh, okay. Not like before that?
No, not before that.
Okay.
We can write.
But I am just showing you these are the things. Anyway, during mock revision session, we are going to show you these are the things we are going to provide you.
But we can consolidate the things, sir. It's all there.
Yes. So these are the things. Okay, no need to remember what is the PMF or PDFs of few well-known distributions. No need to by heart or anything. Okay. Just try to solve a few more problems from week 4. If there is any issue, and yeah, we are trying to have one more session if the students are interested, which we deal with proofs and everything. Okay.
Yes, sir,
Some
we'll
kind
attend,
of
sir.
proofs. Maybe
When
after
it will be,
quiz.
sir?
Yeah, maybe after quiz 1. So they are not included in quiz 1 portion. Okay. So it is something called beyond stats 2 portion. It is something like expanding our knowledge kind of session. Okay, both ways. Even if you have anything interesting topics in statistics too, which we didn't dealt till now, you can bring it up and we can discuss. We can have an open discussion kind of thing. So this is purely knowledge expansion kind of session, not related to anything, not related to marks, statistics to lectures, yeah, exams, some anything, nothing related to marks. If you improve knowledge in this particular distributions or statistics, we can have an open session where we will have complete see this few proofs we didn't give you in between. We just said just believe us, something like that. We can also discuss how they came, how they derived, something like that. Okay, after quiz 1, we are planning to have after quiz 1, right?
Sir, before quiz, will the week 5
we have to
start,
do
sir,
week
syllabus?
5 also. Yeah, because the deadline
Before
we can't
quiz.
postpone. Yeah. Okay.
Hello,
do
sir. So parallel we have to do.
Yeah, parallelly you have to do week 5 as well as the revision of week 1 to 4.
Preparation for quiz.
Sir, shall we have again a week 3 and week 4 revision sessions, sir, like what we have earlier for week 1 and week 2?
We will have a revision session completely on week 3 and week 4.
Okay.
Sir, actually, this festival leaves are there.
One by one.
Quiz 1 syllabus, what will be the?
Quiz 1 syllabus is till week 4.
Up to week 4.
Up to week 4. So
Actually, Shrikantji, this Dasara holidays are there. Can you accommodate in those holidays session? It will help us.
Which session? Revision session?
This revision session. At least week 3. If possible.
Oh, okay.
Because we can.
So
yes, sir.
We have to discuss. Okay. See,
Okay.
Dasara holidays
Yes.
means it is till October 6th or 7th.
9th,
Yeah.
sir.
9?
No,
Yes,
in this week, any time you
Means
can.
up to next Sunday.
Because
Okay, maybe
Office
after the
also is-
deadline of week 4, we can have a session.
no, at
Quiz
least
1
week
October 16.
Huh? Week 1 is
Quiz-
16.
No, quiz 1 is in October 16th.
Right.
Yes. Because for
And
people,
you
we
will have
some holidays. So
Yeah, I understand. We can have one revision session. You are asking us to have one revision session this
one
week and
revision,
another
at least
revision
week
session.
3, something like that.
Okay,
Yes,
we can have week 3 revision session after. See, now do week 4. Now week 4, people are
Yes, sir.
doing week 4. Submit
Yes,
your
yes.
graded assignments till Wednesday.
7th is deadline, sir, for that.
Week 4 deadline is 7th, not 5th.
No,
Yes, sir.
5th.
5th, right?
No, sir.
It is in seventh.
Oh,
They
Seventh,
have
sir.
extended.
they
Yeah.
push the
No,
deadline to
it
7th.
is on 7th, sir, because I hope because of this.
Dasara. Yeah. 5th is
Okay.
Dasara,
Because
right?
5th is Dasara,
Yes,
sir.
yes.
Yeah,
That's why
yeah.
I think.
Correct. So they have pushed to 7th.
So it's on 7th.
Okay, that's good.
Sir,
Okay.
YouTube link of today's session is available now.
Available on calendar only. If you are subscribed to this calendar,
Okay.
calendar itself, you will get the Gmeet link, and below that you will have the YouTube link.
Yes.
So,
Sir, another thing is,
Okay.
if will provide that modified that PDF, no, that will be help actually.
modified matlab? Whatever I
Modified-
written, right?
No. Whatever some correction we are doing.
Corrections are there. I will see.
Yeah.
There are corrections. We will make it and we will update it. The link will be same, but we will update the version. Okay.
Yeah.
Okay, we will do that.
Sir,
We will
like
definitely
this
do
That
week
is a
for
bit,
notes.
please like leave a notification also.
Huh?
When that updation is done, also give some notification or something.
Notification or announcement, is it?
Yeah.
Okay.
So that we know that we have to re-download it.
Okay.
Hello,
So
sir.
did you introduce any other concepts now?
No. We are
Hello,
done with
sir.
week 4, right? Almost in the last session they have discussed
Sir,
till PDF.
I had asked about that practice assignment question number 2. Can we just do that?
So practice assignment question number
2. I have doubt in the first two options. I'm not understanding why the second option is correct but the first is not.
Okay.
Sir, can I ask one question, sir?
Yeah. Let me share the screen.
Just like yes, just like this week 4 complete notes we have got it, no, sir.
Yeah.
Like that is week 3. That's what we discussed today. Isn't
So
it, sir?
Yeah.
Like that week 3, I mean week 1, 2, 3, will they be available, sir?
Week 1, 2, 3 we have to prepare. See, now that we have released week 5,
that's
we
what
are very
you told in the last.
We will release
now
week 5.
I remember.
Okay. Yeah.
Yes, sir. Yes, sir.
So
I
just
understood.
start with week 4 now.
Yes,
Maybe
sir.
by the end of
you
this
said
time,
already.
Yeah. So if you remember that, that is what I said.
Okay. Sir. But week 4 is absolutely very detailed one we have got it. Thank you for that.
Yeah.
So in this session, we are like going to solve the questions only, or we'll discuss the concepts also.
In this session, we are about to end the session.
Sir, can we leave?
From 6
can I leave?
Yeah. So those who are done, you can leave. Anyway, after this doubt, even I will formally close this session.
Okay. So I joined late. I thought it was at 8 p.m. Sir. Sorry.
Okay.
Okay, thank you, sir.
Yeah. Thanks.
Sir,
Thanks
happy
a lot.
Dasra, sir. Thank you.
Thank you.
Happy
Thank
Dasra
you.
to all, and same to you, Lakshmi.
Srikanth, one
Thank you,
last thing.
sir.
One before taking the question, I just want. I'm a little bit struggling in this stats 2. I don't know, from the beginning I'm struggling. Stats 1 also struggled, but I luckily passed. How to overcome, I don't know. I'm not getting the flow as I got the flow in maths and all.
Okay. I just wanted to ask you one thing, Krishnaji.
Yeah.
How much time do you have within a week? How much time?
No, I'm spending for Saturday and Sunday almost 5 hours, Saturday, Sunday.
Okay.
And Wednesdays for assignment I'm spending. And in weekdays, 1 hour I'm spending. More than that, I'm not able to. It's my limitation.
Fine.
But with the same approach only, I could manage maths too. I don't know why stats 2 I'm not able to relate.
Let me tell you one example. If you know how to play cricket, that doesn't mean you know how to play volleyball or basketball, correct? And
if I somehow come out of this, then I can.
The thing is, the rules and restrictions or the methods you follow in something may not apply for all the things.
Yeah,
and in particular,
my strategy.
What strategy you should apply? Not only you, everyone who is doing statistics too, they should be in touch with statistics too each and every day, because we will forget the things. Okay, so human nature, forgetting is an human nature, right? So whatever we learn today, we will forget it. Maybe you will remember it tomorrow or day after tomorrow, but you will forget it after 3 days. For that
one thing, and also see that linear algebra also was new to me, but it was not. I didn't find it so much stressful. But this one I am finding it very. I'm not able to proceed.
Okay, Krishnaji, can you give me 2 minutes? Let me explain.
Okay, no issues. Please continue. I'm sorry.
Other people will leave the session and we can have this. Okay. So this question, right?
Yes, sir. The first two options, the second one is correct and the first is not. Second one says it's approximate and the first one says it's equal. I tried to, I think it should be equal, but
it should be
approximate.
Okay. So let me ask you one thing. So this is densities, right?
Yes. It's density.
That's the density.
So if you integrate it, it will become twice that. If you integrate it, you have to integrate it to find the probability.
Okay. I understood. Is there a Jamboard I can open here itself? Oh, okay. I have to share this. Is it? No. How do I share this? Okay. Anyway, I'm just stopping this screen and I will go back to my journal screen. Okay. So look at here. What does this mean? Fx of 2 is twice fx of 1.
The density function at 2 is twice the density function at 1.
If the density function value is somewhat this, fx of 2 density is this. Correct?
Yes.
So that means if I take my density function to be somewhat like this.
So let us say density function is x, suppose.
Density function is x. Okay.
It can be that, na? Density function is x.
Density function is x. When will that be equal to x? Within the interval only, right?
Yes.
Within some interval. So integrate that interval, I should get 1.
Yes. So x square by 2.
X square by...
Its integration is x square by 2.
Its integration is x square by 2.
And from 2 to 1.
2 to 1 we are not getting, right? It shouldn't be 2 to 1. So you are saying that x, right? It is x.
Yes, yes.
So if it is x, when will I get area under this curve to be equal to 1?
They are not saying that area, it is, they are just talking about the probability distribution. They are not saying it is equal to 1. They are not saying it is equal to 1.
Wait. Okay, it is x in the interval something we say alpha to beta. Okay, but alpha and beta are here. Or else you don't need to worry about taking an example also. Just treat it like your PDF function is like this, okay?
Okay.
Now, what I need is the probability under this and the probability.
Yes. So you have to integrate over that small interval, right?
Small interval.
Yes.
Epsilon, right?
Yes.
So, can you tell me the area under this this particular region will be exactly equal to area under this particular value?
It will not be exactly equal.
It will be approximately equal.
Yes.
Correct? It will not be exact. Depending upon this curve, it will vary.
Yes.
Right? So from here you can get that it will not be exact.
Okay.
Okay.
Right.
So that is how it is.
Can't you just integrate and show it like?
Okay, we will try to come up with an example which.
Let's say x. Suppose we take fx equal to x.
Taking fx is equals to x. I don't mind taking fx is equals to x. Okay, but the condition is if I integrate fx this x dx.
So x square by 2 over 1 minus epsilon 1 plus epsilon, right?
No, what am I
x
saying?
X square by 2 over x square by 2 from 1 minus epsilon to 1 plus epsilon.
I understand, but in order to be this a density function, I should be defining my interval, right? And my 1, 2 should also lie in that interval.
Yes.
Are you getting my point? So you are saying x and 1 should be there, 2 also should be there. And the area under this curve should be equal to 1. It shouldn't cross 1.
Or it should be less than 1.
Even or else it should be less than 1. Yes, but if you see here, this is 1 and this is 1. This is this area. It cannot be a PDF. Taking X and containing 1 and 2 in my density, it will not happen.
Okay, so X cannot be the PDF.
X cannot be.
Fx equal to X cannot be the PDF.
Yes. So something else I should be having, such that this fx of 2 is equals to twice fx
suppose
of 1.
This equation which if you integrate it here, suppose you
integrate it here.
No, the equation which you have written on the top left corner, if you integrate it, you will get say a capital Fx.
So what am I integrating? Integrating
fx at 2 and
no, we cannot integrate like that. So fx of 2 is a value.
Yes,
fixed value. It's not a.
But let us suppose that fx is having a integration capital F. Suppose integration that we can do. No, integration of small f is say capital F.
So, integration of
small f is capital F.
Yeah, Smile. Do you have any inputs in this? Smile, you are on mute. Okay. Your name, Siddharth. Siddharth, what am I trying to do is, I'm trying to come up with an function fx of x, such that this particular thing is satisfying.
Suppose you integrate this small f and you get a, let us say you get a function capital F.
Okay. Okay, I got capital F now.
So at 1 it will be capital F, and at 2 it will be 2 times capital F.
Why?
Because the PDF is twice that of. So if you integrate twice into small f, you will get twice into capital F, right? If you integrate
no, you won't get that.
2 into small f, if you integrate, you will get 2 into capital F, right, sir?
See, 2 into
small f.
Okay. If I integrate this, you will get 2 into capital F. Okay.
Yes. So now this capital F over 1 plus epsilon and 1 minus epsilon, and 2 capital F over 2 plus epsilon and 2 minus epsilon.
Okay, if I wanted to write, so this will be
integration
of 1 plus epsilon. Okay, if you are integrating this with 1 minus epsilon to 1 plus epsilon.
Yes.
So this will be fx of 1 plus epsilon minus fx of 1 minus of 1 minus
epsilon. And here in the small, lower equation, it will be 2 times fx of 2 plus epsilon.
No, 2 times fx.
No, here you have integrated, na, sir. So you have to, this will be from 2 plus epsilon and 2 minus epsilon, right? 2 into fx.
No, see, simply if 2 times fx is 2 times capital fx of x, it is equivalent to saying the above statement only, right? So I didn't understand why only you are taking 2 minus epsilon to. So even I can take here 1 minus epsilon to 1 plus epsilon.
Why 2 plus? Because that is the function at 2. At 2, this PDF is 2 into fx, right? So the CDF at 2 will be 2 into capital fx, right?
Okay. Just a second. Fx, I have given you something called x square, okay? And I said f of 1 is equals to 4 times f of 2 is equals to 4 times f of 1.
Yes.
Is this correct?
Yes, yes, yes.
Now I didn't give this. I asked you to find f of x, something, or integrate fx of x.
Yes.
So will you do something like this, fx of x dx 1 minus epsilon 1 plus epsilon, and other thing is 2 minus epsilon 2 plus epsilon 4 times f of x dx?
That is what the function of, that is what the definition of CDF is, right, sir? So
No.
if you want to get the probability, you have to integrate the PDF. Only then you will get the probability.
Okay, I understand. You have to integrate the PDF, right?
Yes, yes.
You have to
So
integrate the
that is
PDF.
what, so the integration of the PDF is capital F of x, right?
Huh.
Integration of PDF is capital F of x.
Okay.
And at 2, if you integrate it, it will be 2 into capital F of x.
My question is, why are you doing this 2 times?
Because the PDF at 2 is twice the PDF that at 1.
So you are using 2 here and 1 here. Why is that? Why can't I use 2 above and 1 below? See, this x is for every possible value, right?
Yes, yes. Okay.
So this x is variable here. We can't bring directly 1 or 2 into this. Once you bring 1 or 2 into this, it will become a constant value.
Okay.
It is independent of x. Okay. And whatever this and this, if I remove the limits, this and this both are equivalent.
Okay.
Okay. If I multiply 2 times to the left hand side, right hand side will become 2 times. That's it.
Okay.
Nothing else is changing here.
Okay.
Okay. So if I have to convince you with this, like, why will it be approximate? So f of 2 is twice f of 1 is given.
Yes.
Okay. Treat it something like this. So give me a quadratic function which passes from 1 and 2.
Quadratic function.
Okay. Okay, I will take something like x square minus x square 1 minus x square 1 minus x square will be something like this at 1. So I just have to push this little above, side and above. So 2 minus x square, it will be at 2 and this is at 1. So I just have to add a constant. So 2 minus x square when x is 0, y is 2. X minus 2 whole square minus 1. This is x minus 2 whole square minus 1. So if I add some 2 minus x minus 2 whole square. So when x is 2,
okay, it is 2.
It is 2. When x is 1, it is 1.
Yes.
Yes? Okay. Let's try to make this particular thing as the PDF now. Okay. Fx of x is something like 2 minus of x minus 2 whole square and 0 otherwise. We will try to put some limits. So my 1 and 2 should also be inside this.
Yes.
Yes, right?
Yes, sir.
So if I compute the area under this curve between 1 and 2, it should be less than 1. If it is less than 1, this will be a proper PDF. It will be a proper PDF. You are getting this point, right?
Yes, sir. Yes, sir.
So this is minus x minus 2 whole cube by 3. 2 and 1. So 4 minus that is 0. And minus 2. And if I substitute 1, gone. This is 2 minus 1 by 3. I am getting something like Okay, 3 by 2, right? Sorry, 6. 5 by 3. I can multiply some constant, right?
Yes, but it is greater than 1.
Yeah, if I multiply some constant by maybe 1 by 10.
Okay,
if I multiply it by 1 by 10, what will I get? Somewhat I will get, like, when x is 2, I am going to get 4 by 10. I'm going to get 2 by 10. When x is 1, I'm going to get 1 by 10. Okay, it is twice. It is satisfying. And here also, if I multiply by 1 by 10, now it will be 1 by 10 of something like 5 by 3. Now it is 1 by 6. So this is a valid PDF with 1 and 2 contained and also satisfying this. Okay.
Yes, sir.
Okay. Or else you can reduce it. So now let us compute this 1 plus epsilon to 1 minus epsilon to 1 plus epsilon 1 by 10 of 2 minus of x minus 2 whole square dx.
Yes.
Okay. So if I integrate this,
1 by 10 comes out, and then
2x minus
x minus 2 the whole
cube by 3, and limits are 1 plus epsilon and 1 minus epsilon. Okay, and this is something like this. So 1 by 10, 2 times 1 plus epsilon minus 1 plus epsilon minus 2 whole square by whole cube by 3, and minus 2 times 1 minus epsilon minus 1 minus epsilon minus 2 whole square whole cube.
Plus, right? Plus.
This will be plus, correct. And if we expand this, we are going to get 1 by 10 of
4 epsilon.
Okay, this 2 and this 2 will get cancelled. We will get 4 epsilon. And here also it is something like epsilon minus 1 whole cube.
Minus 1 and
so this is 1 minus. So okay, this again becomes minus epsilon plus 1 whole cube divided by 3, and this is minus epsilon minus 1 whole cube by 3.
So one is plus and one is minus, right?
See, this plus will become minus.
Yes.
This will become minus. Okay.
Yes.
So this is 4 epsilon minus. If I expand, epsilon cube plus 3 epsilon square plus 3 epsilon plus 1 divided by 3, and I have taken minus common, then this will also be like plus epsilon cube minus 3 epsilon square. So the even terms will get cancelled out.
Yes.
Plus 3 epsilon minus 1 divided by 3. So this and this
cube
will get cancelled.
Plus
2 epsilon cube. So this will be something like 1 by 10 of 4 epsilon minus 2 epsilon cube plus 6 epsilon divided by 3. Okay, if you simplify this, we are going to get something 12 epsilon minus 2 epsilon cube minus 6 epsilon divided by 3. This is simply 6 epsilon minus 2 epsilon cube divided by 3. You got this?
Yes, sir.
So 3, 5. So we are going to get epsilon minus epsilon. So 3 epsilon minus epsilon cube divided by 15. So this is the final value we got for this.
Okay. For the first term, the second term similarly for
the second term, you try to compute, or I will just try to compute quickly.
Okay, I'll do that and I'll get back.
You do this.
Okay, sir.
You will not get twice of this.
Yes.
Okay.
There will be a slight difference.
There will be slight difference. If you got the same thing, then we have to go for another contradictory example. It will not always be same.
No, I don't think it will be same.
In some cases, it might
you showed the figure also.
Yeah. In figure, you can identify easily that it will not be same. It will be approximate.
Yes.
Okay.
Sir, the Jamboard is not accessible.
See, that Jamboard I just opened and I closed it.
Okay.
I tried to do something on Jamboard, but it didn't work out. I just closed it and I just opened this.
And these notes you will upload today?
This notes I will send it today. Maybe by tomorrow morning it will get uploaded.
Okay, thank you.
Okay.
Sir,
Yes.
I have a doubt.
Yeah, Smile. I called you in between, but you didn't respond. Yeah, tell me.
Yeah, so it is about we know that like for discrete variables we have probabilities, right? Sir.
For discrete,
we are having probability density function.
For continuous, we have probability.
No, for continuous we
density
have probability. Yeah. So my doubt is like we are not associating a specific value to the probability of continuous random variable taking a specific value, right? And my doubt is like, if we do that, is there going to be any problem? I understand how it is working now. Like PDF, how is it working? I can calculate each and everything here. I understand that. It is working perfectly. But if it would have tried to build up the theory that way, would there have been some issue with that?
So you are asking me that if I go with point-to-point probabilities.
Yeah. In continuous random variable, is there possibility of associating a specific value, non-zero specific value to the probability of every number?
See, that is possible if you know which real number will come after which real number. What real number?
No, we do not know that because it's continuous.
You do not know that, right? And if it is continuous, even though however small interval I give, there will be infinite number of possible values.
Yeah, but we can give some function which associate each real number with each probability, right? We can use some functions for that.
See, as there are infinite number of possible values, even if I associate 0.00000001 to one particular value, if I add infinite 0.0001,
we are not going to get
it will cross more than one. It will go to infinite basically.
But no, actually, that's my issue right here only. In the case of discrete, we can have infinite variables, right? Infinite discrete variables are possible, right?
Infinite discrete, yeah, possible.
Yeah, there it is possible. So still there's and there we can associate values. So you are understanding my dilemma here, right?
I understand. See, there is Poisson random variable, so it has infinite possible values, but they are discrete.
There is a probability associated. So I'm thinking in same terms. Why is it not possible here?
So here it is discrete. Okay, discrete mane there is something called countably finite.
Yes.
No, countably infinite. Sorry, countably infinite, and there is something called uncountable.
Yeah.
Okay. So when in discrete case, this whatever the infinite case you are talking about, that is comes under countably infinite. Even though it is infinite, I can count the things.
Yeah.
And I can arrange the things, and I can order the things.
Okay. I understand that. I understand the concept of countability.
So once you can do that, so then you can associate probabilities. Even though if you associate probabilities, it will sum up to 1.
So what you are saying is like, if I have a sequence, and some of that sequence can be finite if they're countable number of terms, and if they're uncountable number of terms, and if they're uncountable number of terms, then some can never be finite.
If you know that thing, I will go somewhat in deeper. That summation, I will bring them series into the picture. Okay.
Yeah, please.
So if you know, if let us say the probabilities associated to each value is pi. Okay. So pi. So if I know this I is countably infinite. Okay, if I know this I is countably, so I represent it as I, this is countably infinite. Okay, so if this is the case, I can get my summation which is countable. This I can write it as summation, and I will have something like once if it is countably infinite, I can arrange the things. I can arrange all the possible values. And let us say the first thing is 0, 1, 2, 3. I can arrange it in order. So P0 plus P1 plus P2 and so on, P infinite, something P infinite. I can have this series sum to be equal to 1. There exists some P0, P1, P2 to P infinite such that the sum will become 1. Okay, I can do this summation if I know this is countably infinite.
Can we now prove that it is not possible for infinite, uncountably infinite?
So if I am doing the summation for summation, when I say summation, that means I should consider all the possible things, right? When I say I, and this is uncountable. So this uncountable means, you know what? Even though you think that you have counted everything, every possible thing, there will always be one thing left.
Yeah.
Okay.
Yeah.
So if I say
like we have diagonal argument, similar to that.
If you remember that real numbers diagonal argument. So real numbers are uncountable. If you write down all the real numbers you know, and you say these are the real numbers, I can come up with a new real number.
Yeah, which is not in that list.
Which is not in that list. Now, if I wanted to associate here, I is uncountable. Okay. You know, however the summation goes, you feel like P0, P1, if you try to arrange it in order, and you say the last term is P infinite. So these are the terms, these are the infinite number of terms. Then you will get one more value, which I say P dash of 0. Even though you say this is the last element, you will get one more thing, which is P1 dash. So however summation you try to end, it will not end there. It will again take one more possible value. It will always take one more possible value.
So actually, okay, so let me give an example to that. Maybe. So suppose like there's a distance of 10 meters between 2 points, A and B, right? And every time you are halving the distance, you're moving half of the distance.
Okay.
So
I move 5 units for the first time, and I move 7.5 units for the second time.
And then So, okay, so this will come under countable, right?
This is countable.
This is countable. Okay. So
and even though you know, you will never reach to 10 if you do like this. So there will always be some delta left over. Okay, some distance will be left over always. Okay.
So like if I say okay, these are uncountable number of terms, and I'm saying it right.
See, when you are saying uncountable number of terms, it doesn't make sense. Uncountable, you can't count the terms first of all. So counting is not possible basically. So you can't count. So that is what it means, uncountable. So you cannot count it, you cannot order it, you cannot fix that these are the only possible values. So you cannot fix it.
But so sir, like as you summed it, PI summation where I is uncountable. And suppose I am saying it is equal to 1. Let's say.
Suppose you are saying it is equal to 1. Okay, let's say.
So if I'm saying it is equal to 1, it came out to be 1. Okay. So can now you, so is there any contradiction here? Can you prove that it is not possible?
See, this is possible. This can be 1, but this PIs will be 0. That's it.
For zeros, how can it be 1? Zero summation is 0, 0, 0.
That is where the confusion arises regarding this continuity. It is not actually 0. It will have some probability at each and every point. Okay. So these are infinite number of
points. That will be very, very small.
Very small.
Yeah, that's how calculus starts, I think.
Yeah.
1 by infinity is 0, right?
1 by infinity is not 0. It will approach to 0.
Yes, but
so there will be some probability, but it is very, very, very negligible. Okay. And if I treat it as having some probability, So if I say if one value, such one value having probability x, okay, for one particular value.
Why do we say 0? Why don't we say it's just x valued by small x?
If we say for one, okay, for some value, let's say it has some probability p. If I say like this and I said it is continuous, okay, when I said it is continuous,
then there will be a jump in the CDF.
No, there is no jump at all. And I said the probability of occurring this to be equal to p. Then the infinite number of reals which are left of x and infinite number of reals which are right to x will also have probability p because it is continuous.
That's not true. Like,
that's
I
not
don't
true,
get
is
that.
it? Okay.
No,
They are not uniformly distributed. Now that you are saying that for uniform distribution.
No. If x is continuous at x, this point x, okay. So let's suppose say in my CDF or PDF, if this is x and x is continuous, when do I say x is continuous? I check the left side, right side, and
left
at
hand limit and right hand limit are equal to the value
at that point, and I will conclude it is continuous. And the left hand side and the right hand side checking, however small interval you pick, there will be infinite number of reals. You understand, right?
Yeah.
So x minus epsilon, x plus epsilon. Epsilon can be very, very, very less, even though this interval contains infinite number of reals.
Yeah.
Correct?
Yeah.
And if this is the CDF, in my PDF also at x, it will be somewhat like this, somewhat curve, or it may be uniform. Okay. The left side of x or the right side of x, the density will be same. So whatever the probability you give for x, the same probability, more or less the same probability will be taken by the left values of x and the right values of x.
But so that would imply, like, if we like extend that argument, if there is a point and its left side and right side have same values, and then for like the point next to other points also have same, then it will imply that all have uniform distribution. So it's not true. Like continuous random variable necessarily does not have uniform distribution. They may have another distribution, right?
Does not necessarily be uniform, I agree.
But you are saying like if a point has probability p, then its left and right points also have probability p. That's what you are saying, right? If that's true,
not
then
equal
you can
to
extend
p.
this.
No, not equal to p. It will not be 0. It will also have some probabilities. Correct?
Get it.
So if I say this is x, okay.
You are plotting the CDF or PDF.
Now I am plotting PDF.
PDF.
Okay. So if I say, suppose if x is continuous at x, then my PDF and CDFs will be continuous. Agreed?
Yeah.
When I say x is continuous, around this x there will be something like this curve. So if I zoom very big, somewhat it will be like this, or it may be like this or like this, but it will be continuous. Okay. Now if I say this is just the PDF, when I say PDF, it is probable. If you are equating it to probability mass function, the probability that x takes, this is this p, right? This is p.
Yes. Yes.
Now the left, as it is continuous, so there is no breaks. Understand? The left values of x will take values, if the curve is like this, slightly lesser than p.
Yes.
Correct? And the right side values will take slightly greater than p. That slightly can be very, very less, but it is slightly greater than or less than p. But it has greater than 0 probabilities. Correct? As we are claiming that this particular p is greater than 0.
Yes.
this will also have greater than 0 probabilities.
Yeah, good.
Now, this particular interval will have infinite number of possible reals. Each of it having more or less equal to p probability. Infinite values will have infinite into p. Correct? If I add the probabilities of it, probabilities of all these reals, it will give me infinite into p. Okay? And which is infinite. If p is not 0, this is infinite. Are you getting this? Infinite p is nothing but I'm just adding all the probabilities inside. There are infinite values. So p plus p plus p and so on infinite times. And that will give me infinite value. Value is infinite, or it is greater than 1. It will go greater than 1. Okay.
Why is it necessarily going to?
Why is it?
Yeah. That's pretty cool.
Yeah. This is non-zero. Once this is non-zero, you are adding the values, and you are adding to infinite. Even though it is like 0.000001, or you add 100 zeros in between and 1. If I add 1 by 1, the same number infinite times, it will cross 1, it will cross 100, it will cross 2000, it will cross infinite, it will cross bigger values also. Okay. So that means this particular probability.
That's why if you want it to be sum equal to 1, then we want that the points like left and right do not have value near to p, right? There should be some sudden kind of jump.
Sudden kind of jump, making it a mixed distribution.
Yeah, so that's why we come to discrete and mixed.
Discrete and mixed.
Okay.
Yeah. If it is continuous, then definitely with this argument, this particular p should always be 0. If p is any non-zero value, I will get the probability. If I add all the probabilities, it will go beyond 1, more than 1.
Yes.
Okay. Yeah. So that is why we come up with this density thing. So what we will do is, instead of talking at one point, we will talk about around and at that point. So whatever you are seeing this effects of 2, see this density is actually probability that 2 minus epsilon less than x less than 2 plus epsilon.
Yes, got it. It's like we define instantaneous speed in a very small interval.
Yeah. Correct.
In the same sense, we are taking very small length interval.
Correct. So,
and at a specific point, you cannot define speed because time is 0, right? So in the same sense, here we cannot define it.
Yeah. Correct.
Yes.
Got it?
Sir, one more doubt, sir. If like
just 1 second. In between, just give me 1 second. Let me stop the streaming. It's already gone 3 hours ago.
Yes.
I'll just stop the streaming.
Yes.
Okay. So I don't